Hello, my name is Deep, and today we're going to be talking about Python. This is a completely brand new video series on the Teaching CS YouTube channel, and we are so excited to bring it to you. So let's get cracking. Regarding opening Python, I think the best website is rebel.it. It's an online compiler where you can type your code and run code. But of course, if you want to use something else, like an offline compiler or a different website entirely, completely your prerogative. So before we start about variables in Python, which is what this first slide's about, let's talk about variables in general, in programming terms. So what is a variable? Well, in normal daily speak, even if we look at it from a higher level entirely, even from a bird's eye view, variables in essence are values that change. That's what we learn in math, right? When we have x, y, a, b, c, whatnot, these are variables we use to do our calculations, our equations. So then you're wondering, why is that relevant in programming? Well, just like in math, when you have to assign values to a certain value, i.e. that value being a variable, and you have to assign numerical values usually, just like that, we have to do similar things in programming languages. Now, in programming, we do often use our variables in very numeric ways, like we do have x equals 20, x equals 20.5. We do assign number values to variables, and these number values in the context of Python are called integers. Now, normally when we're thinking about integers, we're thinking about whole numbers, right? 5, 7, 9, so on and so forth. But the great thing about Python, and it's a very interesting thing at that, is these integers we talk about in Python, they can have decimal points. In programming's sake, these are called floating points, these decimal points, and floats are fractional numbers. And if you think about it, let's say 1.5, right? 1.5 is 3 over 2. That's a fraction, an improper fraction, but it's still a fraction. So even though we are considering that to be a floating value, a float, in Python, we just call it an integer. All numbers are essentially data type-wise, declaration-wise, integers. Now, declaration-wise, note here, in Python, you don't have to specify, usually, there's an asterisk mark there, but 99% of the time you don't, have to set the variable data type. So in many other languages, you have to type int or str in front of the variable name to say, this guy is a variable that is a string, or this guy is a variable that is an integer. In Python, you don't have to do that. The way you do, however, is you set your value using an equal sign. And if you want to be a string, which is a series of letters or numbers, and that's very key here because a string can contain numbers, it's numbers that can't be varied, kind of, because if you have a number that's stored just as a string, let's say if it's just 20 and it's stored as a string, then you have speech marks outside of it. If it's hello world, as in the first example, you have speech marks outside of it. That denotes to Python that is a string. But let's say if you want to convert that string to an integer, and that string is just 20 with speech marks outside of it, then you can convert it to an integer. And that's where you'd use int and str as functions. And that is something we're going to come to very soon. But before we get to that, before we get to converting data, let's think about outputting data, printing in Python. So to output data in Python, we use something called a print statement. And it's very simple. You just type print, print, brackets, and then whatever you want to print. If it's a variable you want to print, then just type in the variable name inside the brackets. If it's text you want to print, i.e. a string, then you have speech marks outside of what you want to output. So in case of hello world, in the first example, your speech marks outside of hello world, and outside of those speech marks you have the brackets, because the brackets show to a print statement, what exactly are you printing? You're making it more specific. And that is how these programming languages work. So now we've talked a bit about user output, i.e. printing. Let's talk about user input. So in output, you don't have to declare a variable for it, right? You can just output what you need to output. You might need to declare a variable to store the value that you want to output, but you don't have to store a value to output. You might want to, right? What it means is, in the previous example, x is 20, you want to print x, then you have to have a value to x. You can't just print x if you haven't defined what x is, right? So you can output without saying a variable. You can just output 20. You don't have to output x and have x be 20. That's your prerogative. And usually it varies depending on the code. But in input, this is very, very different. You must have a variable. Why? Because what you're essentially doing is you're inputting a value from the user. Let's say it's a value, that's a number, or a text, whatnot. So in the first case, it would be a value. Second case, it would be a text, as in for username. then you're basically inputting that value, but where are you storing it? You have to tell the computer where you want to store it. And that is what the variable is being used for. The variable is where you're storing that inputted value, which is why you have to define a variable. And so how do you do this? Well, all you do is, just like when you declare a variable, where you have x equals or y equals or whatever, you do x equals input, so the input function is being used, and note that that input function will be stopped from executing once you've entered the value. And you type in input, then you have brackets. And inside the brackets, this is an interesting thing, you can have a prompt. Now, you have to have the prompt. You can't just have x equals input, brackets, brackets closed. But it's a good idea to have the prompt, because then when the user is running the program, in the console, it will output, please insert value, and then have a space for you to enter your value, 5, 10, whatever it is. Now, in this case, interestingly, the value that's being inserted could be a number, but it would be classified as string. Now, you're probably thinking, why is that? Well, that's very interesting about the input method. The input method in Python, this is very key, always automatically inputs the value as a string. It always inputs the value as a letter. Now, that sounds weird, doesn't it? Because if I'm inputting a number, if I'm inputting 20, why is that a letter? Well, here's the thing. That 20 isn't being treated as a number when we're inputting as a string. That can be modified. That number can't be modified when it is in string form. So then wait, how do we modify it? So to convert that string value into an integer value. And to do that, that is where we come to variable type configurations and conversions. So, before I get to different variable data types, we've already talked about the first two, integers being whole numbers that can be used in calculations, and strings being text. Like I said earlier, the input type automatically makes the value a string, okay? And to convert between string and integer, you just have to put int brackets, int short for integer, or str brackets, str short for string, in front of the variables to convert it. Okay, keep this in mind. Now, we've talked about two important data types, right? The variable data types. But there are two others that do come to be of very, very important use. In fact, the third one will be used very, very shortly later on in this video. The fourth one is a char, a single character. It's basically a shortened version of string, whereby if a string is A, B, C, D, then the char would just be A, or just be B, or just be C, or just be D. Boolean. Now, Boolean is an interesting concept. It's basically where it can be either true or false. Now, what does that mean in the context of computers? Well, if you've already done, let's say, a computer science course, you might have heard of binary numbers, ones and zeros, ones being true and zeros being false. That's how computers work. All computers work with binary, to give a short explanation there. And in order to make sure that you have a Boolean data type, you're basically using a conditional statement. Basically, you're asking the computer, and we're going to explain a couple examples of conditional statements in this video and in later videos, but to give a short TLDR for now, that Boolean data type is so important because if it's true, then a certain piece of code can run or not run if it's false. And that is what Boolean value is. It basically indicates whether or not something is going to run, usually in the context of Python programming and other programming. Now, can Booleans be used for other things? Sure, but that's the most common use case for conditional statements, to test if something is going to happen or not happen. So that's code. So pause the video whenever you want to, but the core essence here is to write a program that asks the user to input their name, age, and favorite color, and then print out their favorite color and double their age. The double their age, quick hint is that you would input the value and you'd do value equals value times 2. Okay? So pause the video whenever you want to. Okay, so here's the answer now. So like I said earlier, you've value equals value times 2 for age. Okay? Now, this is something I'd like to quickly explain if you haven't done programming before. Okay? Usually when we do math, right, if we have x as our variable, our math teacher will get very, very angry at us if we wrote x equals x times 2, because that's not true. X is not equal to 2x. So how does this work? Well, what this means basically is the equal sign here isn't equating two sides. What it's actually doing is it's using this function to replace a value. What that means is age is being replaced by, that's what the equal sign indicates, is being replaced by age times 2. Okay? So that's the essence of how you're doubling in this case. Or if you're doing age is age plus 2, then you're adding 2 to the age value. So now, quick summary on operators in Python. It's basically just like how we do it in normal Word documents, right? If you're talking about 5 plus 2 or something like that. then you just use a plus sign, or 5 minus 2, minus sign. Multiplication sign, your asterisk sign, and your division sign, your dash sign, your slash sign, okay? Now, division and modulus. If you haven't already come across these terms, no problem, I'll give you a very brief explanation. Basically, let me give you an example here. Let's say I'm taking 20 and 5. 20 divided by 5 is 4. Okay, great. What if I'm doing 21 divided by 5? 21 divided by 5 is 4 remainder 1, right? So if it's 4 remainder 1, then what would the division value be when it's finding the whole number? It would be 4. Because even though 21 divided by 5 is 4.2, 4.2 isn't a whole number. It's a fractional point. It's a floating point. And even though Python can store 4.2, the division operator in Python will output the whole number value, which is 4. So what happens to the rest of 1? So that's the remainder. And if you want to find the remainder, use something called modulus. So if you do 21 modulus 5, and to do the modulus, use the percentage sign on your keyboard, then 21 mod 5 would be 1. Because 21 divided by 5 is 4 remainder 1. The 4 is the division part, right? It's the whole number part. And the 1 is a remainder. So that's code. This is a very simple thing. Write a program that inputs 2 numbers using the input statements that we explained previously and find the sum of those numbers. Pause the video whenever you want to. Okay, so here's the answer. So you input X, input Y, note the int because we're specifically mentioning that the input has to be an integer. Save Y, and then you print X plus Y. And num1, num2, those are your prompts. So when you run the code, the prompt given to you will be num1, and then you have a space to type in your number value, your integer number value. So now we come to if statements. So remember how I was talking about booleans? This is where if statements come in. So in if statement, we say if something's true, execute a certain code. This is what we call a conditional statement, whereby when a condition is satisfied, then and only then will the code run. So here's an example of a conditional statement, an if statement specifically. We say A is 33 and B is 200. If B is greater than A, okay, that's the condition here. So we're asking the computer if B is greater than A. Well, is B greater than A? First of all, let's ask that question. Yeah, it is. 200 is definitely greater than 33. So it's greater. Okay, so that means that condition is satisfied to be true, meaning the Boolean value is true. And we talked about binary. In binary sense, a true value is 1, a false value is 0. In this case, it's 1. Okay, that's your binary value. But we don't have to worry about that in the context of Python programming. That's just a logical thing to think about if you think in terms of binary. But if B is greater than A, print B is greater than A. And since that conditional statement is true, the computer will print B is greater than A. So what happens if the statement isn't true? Let's say if we swap the values of A and B. Then what happens? Then B isn't greater than A, right? Because it'll ask if B is greater than A. Well, if B is 33 and A is 200, then that's not true. So that means what happens is that conditional statement won't run, which is very cool because it means that a certain part of code will just won't run, will just not run, if the condition isn't satisfied. Okay, the if statement needs a colon. That's a very important thing before we move on to a condition. Okay, and you also need indentation. Okay, so colon is used to indicate basically what's inside the if statement. What's the code that's going to run if that condition is met. In Python, indentation is very, very important. You use a tab key on your keyboard. And unlike other languages, which use brackets to show if a statement is finished, Python uses an indent, which you type, like I said, with a tab key. If you don't indent it, Python won't know what's inside that if statement. It will assume, in fact, if you don't have that tab, and you still have the print statement, Python will assume that print statement is outside the if statement, which means that it would assume the if statement is empty, which is obviously not what we want. So now we come to the if, elif, else. Elif is basically an else version of an if statement, and else is just an else statement, if you want to look at it just from a word perspective. But on a logical perspective, elif means if the previous conditions were not true, then try this condition. So if I have if certain condition, something happens. Let's say if that condition, first condition, isn't true. If I have an elif, then it will again check for a second condition that I've set in my elif. Okay, if the previous conditions were not true, then we try this condition. If even that's not true, then usually we have an else statement, which means that if none of the previous conditions were true, just do this exception case, really. This case where you have all the other conditions not being true, meaning that the default would be the else statement. The default would be the code inside the else statement. And the default inside the else statement could just be break. A break statement is basically where nothing happens. It comes out of the if statement. So comparisons in Python. So we talked about operators previously. Let's talk about comparisons. So equal to. So usually when we talk about equal to, let's say if x equals 5 in numerical terms, we say 1 equals. But in Python, if we want to check if something's equals, we have 2 equal signs. Kind of to double check if that something is actually equal. If we want something to not be equal, or if we want to check if something is not equal, we put an exclamation mark in front of the equal signs. With exclamation mark and equal sign. Greater than, less than, greater than equal to, less than equal to, just like math. Okay? Nothing much different. So, let's code. Write a program that inputs a number and checks whether it is even or odd. So this comes back to the modeler's point, to give a brief hint, whereby if it's even, the remainder when divided by 2 for an even number will be 0. The remainder when divided by 2 for an odd number will be 1. Okay? So basically what you want to check is, if the modulus value is 0, it's even. If the modulus value is 1, it's odd. That's the logical argumentation. And of course, feel free to check your syntax. Now, write a program to find the maximum between 2 numbers. Pause the video whenever you want to. Basically comparing 2 numbers using an if statement. Note the use of the else statement, which is whereby if x is not greater than y, that's automatically that y is less than x, so you print y. Sorry, if y is less than x, then we print x, because we want to find maximum. And if y is not less than x, then y is maximum. My bad. Note that that can happen error-wise, so be cautious of the signs we use. Typically, if I were to code this, I would just use elif x is less than y. But that's completely your prerogative. So previously we've been talking about conditional statements with one condition, but that's not always true. Let's say we want something to be true only when certain conditions are met, when 3 conditions are met, or 2 conditions are met. Or maybe we want it to be either conditions met. Let's say if we have this condition or this condition can be met. So if either one case happens, then we want the code to run. That's when and or as operators can be very, very important use. And is used to execute a statement if more than one statement is true, i.e. statement 1 and statement 2 is true, then you want the code to run. So if A is greater than B and C is greater than A, then you print both conditions are true, in the first example. Or is used to check if either statement is true. Okay, one statement is true, or another one is. As we see in the second example. Let's code. So we write a program to find the maximum between 3 numbers. This is a very common question actually, so I'd recommend you pause the video, think about it for a bit. I'm not going to give you a hint, and think about how this works. So I showed you in the previous slide how to compare with and or. So think about that and use multiple conditions to try and find a program to find a maximum between 3 numbers, because this is a very common question that comes up in competitive programming. And this is the answer. Note that the first 2 if statements, the if and elif, are very similar to, ta-da, to here, with the and statement example. And that is the last example. I hope you enjoyed this video. Thank you for watching. Please like and subscribe if you want to see more of our content. This is Deep Saha, signing out.